What catalysts do? How do catalysts work in chemical reactions? Catalysts are substances that speed up a chemical reaction without being consumed in the process. In a chemical reaction, the bonds between atoms get broken, shuffled around and put back together, creating brand new molecules. Catalysts make this process faster by providing an alternative pathway with a lower activation energy that is minimum energy that needed for a reaction.
Here's the graph of activation energy, which is the minimum amount of energy that must be available to reactants for a chemical reaction to occur. Activation energy of catalyzed reaction is lesser than the activation energy of uncatalyzed reaction.
Let's look at an example of how a catalyst works. Have you seen the elephant toothpaste experiment?
Take half a cup of hydrogen peroxide in a bottle. Add a big squirt of dish soap into the bottle, and swirl gently to mix. Add a few drops of food coloring into the hydrogen peroxide, and swirl the bottle gently to mix to get foam in a different color. Let them drip down the inside of the bottle, but do not mix it. Then, in a measuring cup, mix 1 tablespoon of yeast and 3 tablespoons of warm water. Stir for about 30 seconds. Pour this mixture into the bottle, then step back and watch your reaction go. What happens? How long does the reaction last?
The reaction produces a large volume of oxygen gas, creating a foamy eruption that resembles toothpaste being squeezed out of a tube. In the experiment, hydrogen peroxide mixes with a catalyst, such as manganese dioxide or potassium iodide. This interaction rapidly causes hydrogen peroxide to break down into water and oxygen gas. We mentioned that the catalyst for the elephant toothpaste can be solid, that is manganese dioxide, or liquid, that is potassium iodide. Did you know that the states of the substances involved in the reaction also influence the speed at which the reaction occurs? If potassium iodide, liquid, is used as a catalyst, the reaction will proceed more quickly because it shares the same state as the reactant, that is hydrogen peroxide. This type of catalysis is called homogeneous. However, when you use solid manganese dioxide as a catalyst, the reaction happens slower, because the liquid hydrogen peroxide must first diffuse to the surface of the catalyst before a reaction can occur. Since the states of the reactants and catalysts differ, this is called heterogeneous catalysis. How important are catalysts? Catalysts are used in plastic production. They facilitate the polymerization processes, where small molecules called monomers join together to form long chains or polymers, which are the basis of various plastics.
One catalyst in plastic production is called Ziegler-Natta, which is an organoaluminium compounds contain bonds between aluminum and carbon atoms.
Ziegler-Natta controls how the monomers of plastic stick together. This catalyst helps make plastics with just the right properties, like strength or flexibility. Enzymes, which are natural catalysts, help in digestion and other vital processes. One example is amylase, which acts like a molecular scissor. It cuts the long chains of starch into smaller sugar molecules, this process called hydrolysis. So, catalysts make chemical reactions faster without getting used up. They play a significant role in industrial processes and in biological processes.